a concept that you might encounter if you're going to study a little bit more spectroscopy and lasers is their parametric resonance. What is a parametric resonance? It's a situation in which we have some time-dependent parameters inside our equation that are actually periodic. So if we have again our oscillation equation, and we have now that omega dip is time dependent, and of course it must be periodic as said, with period big T. In this case we can find two solutions to this problem. Now these are the two solutions you can find to the problem, where these big pi functions are simply periodic functions with period big T. In this case we can see that this is this exponential part, and so actually if the modulus of mu is different from 1, one of the two solutions will grow exponentially in time, and so actually where we find ourselves in an unstable equilibrium, and our system will move away from it without reaching it again, without completely changing its position and its situation in time, so finding somewhere else probably a different minimum. But the interesting thing is when our parameter has only a very small oscillation around one kind of equilibrium position. So if actually our time-dependent parameter is incredibly similar to our equilibrium value, but there is only this small oscillatory and periodic perturbation, because h is much smaller than 1, then we can find an approximate solution that will be linear. So as we see in this situation, our amplitude grows linearly. This is of course an approximated solution, but that can be used for these situations, and that's of course much more comfortable to use than an exponential one. So if you can use it, of course your life will be easier.